We're going to take a look in this video at getting some more practice with solving equations. And we're going to look at some more complicated equations. If we take a look at a question like this, remember now we're solving for x. So we have x over 2 plus 3 is equal to 6. And so now what we've introduced here is we have a fraction. So what you have to do first is you have to isolate for the fraction. You've got to get the fraction all by itself because that's where the variable x is. So let's go ahead and get that by itself. And following from solving equations 1, we need to get rid of this 3 first of all. Remember, we do opposite of bed mass, or opposite of order of operations when we solve equations. So we do the added and subtracted terms first, and then we look after the multiplied and divided terms. So here we have a plus 3. Remember, we always want to do the opposite. So to get rid of this 3, we want to subtract 3 from each side. When we subtract 3 from each side, then we have x over 2 plus 3 minus 3 is equal to 6 minus 3. And notice that we've done the same thing to both sides, and here is the negative 3. And if we do the same thing to both sides of the equation, then it doesn't change the value of the equation or the value of the variable that we're solving for. And so now this left side simplifies into x divided by 2, and the right side simplifies into 6 minus 3, which is 3. Now what we have is we've isolated for the term that has the x in it. And now what you see is we have one fraction on the left and we have a number on the right. Well, let's make that a fraction, and remember we can put any whole number or integer as a fraction by making a denominator of 1. And now what we're going to do to solve for x is we're going to cross multiply. This is an operation that is totally allowable in mathematics. If you have one term or one fraction on the left and one term or one fraction on the right hand side of the equation, then you can cross multiply bottom to top and bottom to top. And so the next line will look like x times 1, which we didn't have to write the 1, but x times 1 is equal to 2 times 3. And now x times x is x, and 2 times 3 is equal to 6. And when we plug this back in, and remember we always have to go right to our original equation, when we plug a value of 6 back in here, and if we just ignore this negative 3 and positive 3, because all we're doing here is checking, we have 6 divided by 2, and 6 divided by 2 is 3, and then 3 plus 3 is equal to 6. So we can check our solution and make sure that we've found the right value for x. So that's how you deal with solving an equation when you have a fraction. Now, what about something like this when the variable is in the denominator of a fraction? So let's look at a simple one like 3 divided by x minus 1 is equal to 5. Well, we've got to do the same thing. We notice here that we have fractions, so the first thing we should do is get rid of our negative 1. And so we add 1 to both sides, and our equation now becomes 3 divided by x is equal, 3 divided by x, oftentimes we don't write the plus and minus, minus 1 plus 1. This is the part that sometimes we don't write because we know it cancels always to 0. And that's equal to 5 plus 1. And so now we have 3 divided by x is equal to, and 5 plus 1 is 6. And so now what we're going to do is, we notice we have our variable in the denominator. And so what we're going to do now is we're going to represent 6 as a fraction over 1. And now we're going to cross multiply again. And we're going to see something a little bit different here. But when we cross multiply, we'll end up getting 3 times 1 is equal to 6 times x. and 3 times 1, simplifying the left-hand side here, is equal to 3, and 6 times x. Remember, oftentimes we don't write this multiplication sign in the middle, and so 3 times x, pardon me, 6 times x will be 6x. And so we've added one more step here, and you'll notice when the variable is in the denominator, we're going to have to do an extra step here after we cross multiply, and that is we're going to have to divide. Because now we want to get rid of the 6 from the right-hand side of the equation. And remember, right in here is a multiplication sign. So how do we get rid of the 6? We do the opposite operation, or we divide by 6, and we must do the same thing to both sides of the equation. And the 6's cancel, and we're left with 3 divided by 6 is 1/2. And so x equals 1/2, or 1/2 equals x. Remember, we can read an equation from left to right, or from right to left. That's the whole power of the equal sign. And so now if we wanted to double check here, let's just work on the left-hand side. We have 3 divided by 1/2 minus 1. And let's see what that equals. Well, remember, when we divide fractions, we invert. So I'm going to represent 3 as a fraction of 3 over 1. We invert the denominator and multiply. And so we get 3, instead of 3 divided by 1/2, we get 3 times 2 over 1 minus 1. And 3 times 2 is 6, and 6 minus 1 is 5. And we see that 5 is on the right-hand side of this equation. So indeed, x does equal 1/2. And one more example I want to show you is sometimes you have brackets when you have an equation to solve for. Let's look at an equation like 3x minus 5 is equal to 2 times bracket x plus 1. Now, when you have brackets, you know that you have to do your order of operations first, and you have to do the brackets first. Now, don't get confused here. When you solve an equation, you do the opposite of BEDMAS. But right now, we're not solving the equation. We're just expanding and getting rid of our brackets before we solve. And now we have 2 times x plus 1. So we have to times the 2 by the x and the 2 by the 1. And you might have seen this before or might not have, but that's how you get rid of a bracket when you have a number multiplied by something inside the bracket. And so the right-hand side of this equation will become 2 times x is 2x, and 2 times 1, positive 1, is positive 2. And now we have 3x minus 5 is equal to 2x plus 2. And so now we've got rid of our brackets, which is the main part of this question, and now it becomes relatively easy to solve. Remember, we always want to move the x's to the side of the equation that has the larger amount of x's. And we see 3x's over here, so see if you can follow this one. I'm going to, first of all, take care of my constant terms, and I'm going to add 5 to each side of the equation to just isolate for the x on the side that we're going to move. And so now we get 3x, and the 5's cancel, and that's equal to 2x plus 2 plus 5. And if we simplify the right-hand side, we get 2x plus, and 2 plus 5 is 7. And now what we need to do is collect our terms with the x's on the left-hand side. So we're going to subtract 2x and subtract 2x from each side. And so this will leave us with 3x minus 2x is equal to positive 7. This 2x and negative 2x will cancel each other out. And now 3x minus 2x is just 1x. And so we've solved now, and x is equal to 7. And now we can plug back into the original equation, and we're going to have to work both sides of this equation. So I'll do that over here. So we have 3 times x, which we said was 7, minus 5. 3 times 7 is 21, and 21 minus 5 is 16. And now let's see what happens when we plug x into the right-hand side. We have 2 times x plus 1. So 2 times 7 plus 1 do our brackets first. 7 plus 1 is 8, and 2 times 8 is 16. And so you see we get the same answer, and we've checked our solution again. So that should give you a little bit of a better idea of solving more complicated equations in one variable when we're solving for x.